Hi, good morning, good afternoon, good evening, wherever you're watching this from. My name's Robin Moffat. I'm a developer advocate at Confluent, and I'd like to spend the next half hour talking to you about Apache Kafka and ksqlDB and how you can build some really cool pipelines using these technologies to get data streaming from one place to another, building simple just little connections, but also starting to transform and process this data along the way. So I'm going to walk through a demo. There's no slides or anything like that. And the demo itself is over on GitHub. So you can actually go and clone this repository and go and try it out for yourself. You just need Docker and Docker Compose. And you'll probably see me doing this whilst I'm recording it because the script itself is a cheat sheet over here. And as much as I know this stuff and I want to share it with you, I'm not always good at remembering all the different things to type in. Hence, I've got a little cheat sheet over here. So let's get started. So to start with, I'm going to use ksqlDB itself, which I'm going to explain as we go through what it is, but for the moment, it's just a command line interface that lets us easily work with the data in Kafka. And I'm going to use it to look at the topics that I've got on my Kafka cluster. So I'm going to say show topics, and we're going to see which topics we've got on the cluster. And it says you've got a couple of different topics, and we're going to have a look at this one. So ksqlDB, whilst it can do like complex stream processing and key value lookups and loads of cool stuff like that, you could also just use it for simply consuming data and even producing data as well if you want to from your Kafka topics. So we're going to say print ratings, and this is just going to run a consumer against the topic. Now the cool thing is it goes and looks at the data and it figures out how it's been serialized. So you don't have to say, oh, I'm going to use the Kafka avro console consumer, or I'm going to run the console consumer and get a bunch of bytes back that kind of like, what on earth is this stuff? It figures out how to deserialize it. So it's okay, here's the data. It's probably an avro, so I'm going to deserialize it as avro. And now we can see the data in our Kafka topic. So if I pause the screen for a moment, we can see the kind of data we've got. It's ratings, it's reviews, probably from a website that people are going along to and they're leaving these messages. They're saying, oh, I was really happy with this thing or I wasn't happy with this thing. And the payload looks like this. We've got a rating ID. We've got information about the user ID, the star rating, 1 to 5. 5's brilliant, 1's awful. We've got the time at which it was left. We've also got a message that they left. And they've also got the channel. So the channel is the device. Was it iOS? Was it through the website? Was it Android? So it's just bits of event information in a Kafka topic. The first thing we're going to do here is we're going to take this stream of data that's in a Kafka topic that's getting there probably from a producer API on a Java application or something. Take this data in a Kafka topic and stream it over somewhere else so we can start to visualize it and just like inspect that data as it arrives. So we're going to send it down to Elasticsearch, which is a document store, a document database, and we can take this data and just send it over there using something called Kafka Connect. So Kafka Connect has got a REST API. Kafka Connect itself is part of Apache Kafka. And then you have different plugins from different places, the community and vendors and so on. And using Kafka Connect, you can just specify a bit of JSON that says, take data from here and go and put it over there. Or take data from this system and stream it into Kafka. You can use the REST API directly if you want to. You can use Confluent Control Center, which is a web-based interface for it. You can also use ksqlDB itself, which has got the syntax to wrap around Kafka Connect and control it directly. And that's what I'm going to do here. So let me clear my screen, and we've got this. We're going to say we're going to create a sync connector. We're going to use the Elasticsearch sync connector. I'm going to take data from this topic and send it over to Elasticsearch at this place. I say go and do that. It says it's created it. And we'll say show connectors just to make sure. And it says we've got the sync connector here, and it says it's running. We've also got another connector here, a data gen connector. And that's actually the source connector, because believe it or not, that wasn't live data that I showed you streaming in before. That's just a data generator that's ticking away, mocking up that data and sending it to the ratings topic. So we've got data arriving on a topic, and now having created that connector, we've got data streaming from that topic down to Elasticsearch. So let's head over to Elasticsearch and have a look at it. I'm going to use Kibana here, which is a front end on top of Elasticsearch. I'm going to say create an index pattern, which lets us reference the information that we've got within Elasticsearch. So it's called ratings is the index that it's created. We've got a timestamp field, and we go and create that. And then using this, if I move that to the top of the screen and say go to the Discover view, we can see within here, let me tell it to go and refresh it. So refresh it every second, which probably won't do my web browser many favors in terms of CPU usage, but it lets us see that data as it's flowing in. So you can see that you've got the timestamp there, that's ticking over continually. And if I go back to ksqlDB, and if I run that print statement again, we can actually see as the data is flowing into the topic, it's flowing straight over into Elasticsearch. So you've got a live stream of data arriving in a topic and straight over to Elasticsearch. So Elasticsearch here is our sink that we're sending the data to. But if we look at the data, let's go and switch over to, and this is why using something like Elasticsearch in Kibana is useful, because we can start to analyze that data easily. So I'm going to pause this because we don't want it refreshing so much. And I'm going to go and have a look at the data. If we look at the channel here, so this is one of the neat things that Kibana does for us. It lets you start to quickly visualize characteristics of the data. And we can see within the channel, we've got iOS devices, we've got web devices, we've also got this test one here. So it turns out within our live stream of data, we've got some test devices that are still reporting into that topic, and we don't want that to happen. And I guess we could go to those devices and say, please stop doing that. But we could also say, well, we've got what we've got. Let's take that topic, and now we can start to filter the data and route it as we need to. So I'm going to head back to ksqlDB for this. So here's my ksqlDB window. I'm going to clear that. And because we want to work with data within that payload, simply saying print the data, so here's printing it, just like here's the whole message, that's not actually enough for what we want to do. Because what we want to do is we want to say, take a field within that data and build ourselves a predicate against it. So let me clear that. And what we're going to do is we're going to say, I'm going to create ourselves a stream. So a stream is a ksqlDB object type, and a stream is an unbounded series of events, just like a Kafka topic, except it has a schema. That's the key difference here. So we're going to say create a stream ratings against this existing topic and deserialize the value part of the message using avro. And we go and do that. And we can do this, describe ratings, describe our stream. And it says, well, there's the schema for your stream. Because we have a schema, we used avro, it came from the Confluent schema registry. It was stored when we produced the data into the topic. So as users, we can now consume data from that topic, we can deserialize it, and we have the schema. And this, by the way, is a great reason why you should be using avro, protobuf, JSON schema with your data in Kafka, whether you're building pipelines, whether you're building services and so on. Something with strong support for schemas makes life much easier for people wanting to use that data. So we've got the data, we've got the schema now, and now we can apply projections to that data using these fields. So say, let's select the data from this particular stream. So select just a handful of the different fields from this stream, and now we can use a predicate where the channel, and we'll force it to lowercase just to kind of like in case there's other sorts of data in there, where it doesn't match this wildcard pattern. So where it doesn't match test. Emit changes, and now we get to see as the data arrives on the topic, any messages that don't match that pattern. So that's useful. That's now our live data, excluding the test data. And this select statement's just writing the messages out to the screen, but we can take that select statement and we can say to ksqlDB, well, instead of writing it out to the screen, go and write it to a Kafka topic. And to do that, all we need to do is at the beginning of that statement, we're going to prefix it, and we're going to say create stream ratings live as. So create a new stream, give it a name, as the results of this select statement. And at this point I could override the topic name it's going to write to, or the partition count, or the replica, or the serialization format. If I don't do any of that, it'll just use a bunch of defaults and it'll write to a Kafka topic of the same name as the stream. So we go and create that, and we say show streams, and we've now got a new stream. So we've got a stream called ratings live, backed by a topic of the same name. So the first stream we created was saying we're kind of like declaring that stream against an existing topic. Whereas now we've done the inverse. We've said go and create a stream, and when we write into that stream, persist that in a Kafka topic. And we could say show topics. And we can say topics here. We've got a new topic called ratings live, and I could say print ratings live. So just run a consumer against ratings live, and now you can see the messages as they come in. And if we eyeball it here, look at the channels as they're set, you can see there are no test messages coming through there. So we've taken a Kafka topic and we've filtered it, just showing the messages that we want to use. So this is pretty useful. But we can do a lot more than this. We could use ksqlDB to change the serialization formats, to kind of like drop fields and do that kind of thing. But actually, how about those users? So these users that we've got here, let me just pause the output for a moment. We've got user ID 8, we've got user ID 10. Some of them leave good reviews, some of them leave bad reviews. But who are those users? Who's coming along to our website saying, oh, this is rubbish, I'm probably not going to come back and buy anything from you again? Well, this user 8, maybe they're a really important customer. Maybe they're not. How do we know? Well, this user ID here is a foreign key out to our primary key of the users table, our customers table. And whilst our events here, our ratings information happens to be coming from like a producer API, from like our website or whatever, maybe we've got information about our users stored in a database, or a flat file, or a REST endpoint somewhere else, or a message queue, or anywhere else. We can use Kafka Connect to pull that information into Kafka, and with the data in Kafka, we can do joins on these messages as they arrive and find out exactly who user ID 8 actually is and what their characteristics are. Are they an important customer? Are they not? So let's go and do that. So to start off with, I'm going to show you what we've got in terms of our user information. So this is stored in a relational database. It's in MySQL. Now, it could be MySQL, it could be Oracle, it could be SQL Server. It's a relational database. And what I'm going to show you here applies across the board. If you're interested in getting data between databases and Kafka, there's a talk I did at Kafka Summit New York 2019 called No More Silos, Integrating Databases and Kafka. And this goes into the nitty-gritty of change data capture. There's two different methods. There's log-based, there's query-based. What are the pros and cons of each? Which tools and technologies are available? I'm not digging into that here because it's a whole talk in its own right. But here we're going to use MySQL, we're going to use change data capture from the bin log, we're going to take a snapshot of the table to start with, but we're going to end up with a mirror of our database's table state within our Kafka topics. So let's just check out that database table state to start with. So we've got a table called customers, and we can say select from the customers. We've got our ID, we've got our first name, email address, club status. This is going to tell us about the customer's characteristics. Are they a platinum user? Are they a bronze user? Are they important? Have they spent loads of money with us and we want to make sure we retain their business? Are they bronze? And so on and so on. So let's pull that information through into ksqlDB. So to do that, we're going to use Kafka Connect again. And again, we're going to use ksqlDB as our wrapper for that. So let's pull that over here and bring that up here and clear the screen so we can see what's going on. And here's our statement. It's a bit longer than last time, there's a bit more configuration, but it's just creating a connector using a particular connector class. So it's the MySQL connector from the Debezium project. Here's where our database is at. Here's the table that we'd like to monitor and take a snapshot of and pull every single subsequent change. Every update, every insert, even the deletes we can pull through from that source database. So we go and do that. And if we say show connectors, just to make sure it's working, it says it's working. And if we say show topics, we can see we've got a new topic here called customers. So let's have a quick look at that. We'll put it in quotation marks this time because we've got mixed case and so on going on there. From beginning, so change the offset and go back to the beginning of the topic and show me the contents. And it says, well, there's the contents of your database table. You've got your first name, your last name, your email address. Everything that was in that database table is now in a Kafka topic. What about if we change something in the database table? Well, let's go and do that and see what happens. So we're going to insert something into our database. So in MySQL at the bottom of the screen here, we're just going to run an insert. So we insert into the database, and now our Kafka topic, if you blinked, you probably missed it, our Kafka topic now has that new message, that new event within it. So we change something in the source database, insert, update, delete. That's now as an event within our Kafka topic also. So you've got your full snapshot plus every single subsequent change to that table. And with ksqlDB, we can model this stream of events from the database table, and we can model it as a table. We can say, never mind the events, what's the current state? So for a given key, what's its value? For key 42, who is that user? What is their club status? What's their email address? What's their name? And if that key value changes in the source database, we'll reflect that in ksqlDB also. So we're going to do this here. We're going to say create ourselves a table in ksqlDB. So instead of creating a stream this time, we're saying create a table. So create table against this particular Kafka topic. It's in avro as before. This time we're going to specify a key for the table because tables are key value state. So we create that table and we can say describe customers. and it says here's the schema. We've got the schema because Kafka Connect took the schema from the source database, it stored it in the Confluent schema registry, so when we come to use the data, you'll notice I didn't have to type in a schema. I just said, go and create this table, this is the key, all of the rest of the schema comes from the schema registry, so it makes it much, much easier to work with this data. And using that, we can go and query it. We can say, go back to the beginning of the topic, set the offset to the earliest, and now show me the contents of that table. It says, well, here is the contents of that table. For every single key, here is its value. And if I run that same query down here in MySQL, say select it from customers and show me everything, it says, well, here is the contents. Let's resize that a bit so that you can see. So we've got all of our different users, we've got their first name, last name, email, and their club status. So you've got a complete mirror of database table into a Kafka topic, which is then modeled as a ksqlDB table. We could take that same topic and model it as a stream of events if we wanted to. It's just we're asking different questions of the data. One is, what's every single event, every single message as it arrives, an unbounded series of events. One of them is, given these key, what's its current value? And now that we've got a table with values within it, we can do a join between that and those source events as they arrive. So let's do that join now. So here is our select statement, and it's going to look like this. So let's page that down there and clear the screen. So here's our rating information, here's our customer information, and it's just a SQL statement. So select from here, do a left join to here. This is a stream table join. So our stream is the ratings topic, our customers, our stream is our ratings stream, and our customers is our customers table. So we're doing a left join between that. We're saying emit changes, we want to see the changes as they happen. And now we get a full screen of stuff because we've gone back to the beginning of the ratings topic, we'd set the offset to earliest. And as we're going through this, ksqlDB is resolving that join and it's saying, here is my rating, here's my ratings message, here's the device, and here's the user. You'll notice I've got a few test messages in here because I did a join out to the ratings original stream, not the ratings live stream. So you can go and fix that in a moment if we need to. But we're seeing for every rating as it arrives, if I go back to the cancel that and go to the latest information as it's arriving into the system, every single message as it arrives in brings in with it the information about that user and their club status. So instead of writing it to the screen, let's go and write it out to a ksqlDB stream and thus a Kafka topic as well. So exactly as before, create stream as select. And here we're saying, well, we're going to override the Kafka topic and we'll give it a different name because that's what we want to do here. So we go and create that stream. And we say show streams. We've got a new stream. The stream's called ratings with customer data. We can even say describe it, and we can see it's got a schema. We could say describe extended, and we've got statistics about it. We've got like the query that's writing into it. We could run an explain against it if that's your kind of thing. We've also got metrics. How many messages have we processed from that source topic joining out to the customers? And if I run that describe extended again, you'll see this total messages here will go up from 3833, 38881, 3885. It's a live stream processing application that we've written expressing what we want to do using SQL. We're going to run another one here. We're going to say, let's take that data that we've refined and we've enriched with the customer information. Now let's take that and we'll say, if a customer comes along and needs a review that's not very good, so like on a scale of 1 to 5, 5 being brilliant, it's less than 3. So it's 1 or 2, they're not very happy, and they're a platinum customer. And we can only do this because we've already resolved that join by having that information out to customers within a Kafka topic. So if they're a platinum customer and they leave a negative review, let's go and write this out to a new ksqlDB stream and thus a new Kafka topic. Now if we have a look at our topics, we've got a topic here called unhappy platinum customers. And we can say print that. And we'll see here is the information about our customers who are leaving negative reviews here and now. We can write a microservice that subscribes to that topic, and now we have this event-driven process which says if a negative review is left by an important customer, go and do something now. Don't analyze our data next week and see what happened last week and find out our customers were unhappy. When something bad happens, let's do something about it now. I'm going to take this data now and we're going to go and stream it down to Elasticsearch, and we're going to build ourselves a dashboard that looks a bit fancier than the one that I showed you previously. Again, create connector. Let's take the Elasticsearch Sync connector, take the data from these two different topics, because you can take data from multiple topics in Kafka Connect, multiple source objects into Kafka, multiple topics from Kafka down to the target systems as you want to. So we've created that connector, show connectors, and we can see we've got connectors are all running, which is good stuff. And now let's head over to Kibana again. So I'll put this on the screen. So what this is going to do is going to show us, using the data that we've got from our Kafka topics, we've enriched with information about our users, and we're streaming down into Elasticsearch. And if I set this here and set it to refresh, we can see we've got a near real-time dashboard that's showing this enriched information. It's building ourselves some nice visualizations, breaking down the data by different characteristics, by different dimensions. We can see our Platinum customers here. We've split those out into a separate topic and we're handling those separately. We're building some aggregations down here. We've got our live stream of information here, and it's near real time. So we've got our producing application, producing its data to a Kafka topic. We've got our database doing its databasey things, storing state about our customers, which we've got Kafka Connect streaming in to a Kafka topic in near real time. So as something changes in the database, plus a full snapshot of those tables into a Kafka topic. The event arrives, we enrich it with ksqlDB, it gets written to a new Kafka topic, and that gets pushed down to Elasticsearch. So we've built this using a bit of SQL and a bit of JSON for the for the Kafka Connect configuration. Now, when it comes to building stuff with computers, it's always about using the most appropriate tool or technique, depending on what you want to do. So here you can see I've filtered out those Platinum users, and we're doing that bit upstream and pushing that enriched Platinum section of the data down to Elasticsearch separately. Now, of course, you could push the raw information to Elasticsearch and do that filtering in Kibana. Another way around, within Kibana, within Elasticsearch, we're building ourselves some aggregations. We're saying, look at the devices that were used to leave these ratings and summarize up, broken down by time window, the different numbers. But sometimes we want to do those aggregations up front. As the data arrives in our system, we want to build those aggregations. That could be because we want to pre-populate or pre-calculate aggregates to push down to a reporting system where we don't want to store that raw data and roll it up at runtime. We want to pre-calculate those aggregations and just store the total aggregate value down in the target system. Perhaps we want to calculate those aggregations and query that state from applications here that want to know the value as of now. We don't actually want to take that data and store it elsewhere. So let me disable this because we don't want to be refreshing that whilst we're trying to do other things. And we can take ksqlDB and use it to build these aggregations. So that's what I want to show you now. ksqlDB, we're going to say create an aggregation against this data, and the result of an aggregation is a table, because a table is key value state and an aggregation is a value for a given key. The key is going to be made up of a group by column or columns, and in the case of a windowed aggregation, which is what we're building here, it's also going to have the timestamp of the window within the key as well. But if you think about the key that's the data that we're processing here, we're saying for each user, how many ratings have they placed, broken down by user, within a 15-minute window. And that data is going to keep on arriving. So that aggregate for a given 15-minute window is going to keep on increasing. With ksqlDB, you can build windowed aggregations. You don't have to use a windowed aggregation. You can also aggregate your data over like all the data you have, but typically you'll break it down by a window. That could be a tumbling window, it could be a hopping window, or a session window. So here is a tumbling window, and the offset of windows is always based on the Unix epoch. So starting at midnight, back in kind of like the 1970s. So here we're going to say, as of midnight, as of quarter past midnight, half past midnight, and so on, how many events have occurred within that window. So we go and create that, and now we can query it. So we can say show tables. And an important point about tables, just like with streams, when we create stream as select, it builds a stream that's persisted into a Kafka topic. When we create table as select, it creates a table that's persisted as a Kafka topic. The only difference is that when we're building these aggregations, that stateful aggregation is stored within ksqlDB itself. It uses something called rocksdb, and this state we can actually query directly. I'm going to show you that in a moment. So we've got our customers table, it's persisted, sorry, not our customers, we got our ratings per customer table persisted in this particular topic, and we're going to go and query that table. So we're going to say for a particular user, show me how many ratings they've left per 15-minute window just for this user here, and we're going to say emit changes. So this is called a push query. For this particular user, tell me every time these values change. So say, well, here are the particular aggregate windows, 11:15, 11:30, this many ratings, and then these are the different ratings themselves. You'll notice there it changed. We got a new value pushed to us. It's because it's an emit changes, it's a push query. So as these values are arriving during this time window, which is now, the aggregate updates, the state updates, and thus we get a new message written out to us. But perhaps we don't actually want to receive a message every time it changes. We just want to know, as of now, what is the value? What is the state? And we can do this using what's called a pull query. So here's a pull query. It's basically the same thing. It's still a select query, but it doesn't have emit changes on the end. So we're going to say, let's run that for this. I'm going to say for that and for this. It says, well, here is the current value for that time window. So here's the particular key, here's the particular user, there's the particular time window, and that's the value. Has it changed? I don't know. Well, I guess I could go and query it again. And in this sense, it's just like querying a relational database. What is the state? I'll run a select. Here is the state. Has it changed? I don't know. I'll go and run that select again. I can run that select again, and it turns out the state has changed. But this is a pull query. We're going to the database, the ksqlDB, and we're saying, what is the state for that key? And it says, well, here it is. So I'm using the command prompt, the ksql CLI. You can use Confluent Control Center. There's also a REST API. There's also a Java client that's just been released. So however you want to pull this data out of ksqlDB, you can do so. So instead of running a pull query through the command line interface, let me show you how you can actually do this using Postman here as an example. So we're going to say, let's take that same query. We're going to go against the query endpoint of ksqlDB and say, what are the current values for this particular key? And we go and send that to ksqlDB, and it says, well, here are your current values. For this particular time window here, for this particular key, there have been 75 different ratings. Has that changed? I don't know. Let me resend it. So we send that, and it says, okay, for this one, now it's 76. But you can use ksqlDB to do key value lookups against the data. So this is really, really useful. So you materialize the state within ksqlDB with an aggregate query, and then you can query that state directly. So we've seen in this talk how you can take that data from an Apache Kafka topic, how you can filter it, how you can push it down to different systems. We've also seen how you can build stream processing topologies using ksqlDB. ksqlDB itself is built on top of Kafka Streams. Kafka Streams is a Java library, it's a part of Apache Kafka. So if you prefer writing Java to SQL, you can go and use Kafka Streams. Everything I've shown you here, because ksqlDB is an abstraction on top of Kafka Streams, you can do everything that I've shown you in Kafka Streams directly if you want to, or using Kafka Connect with its REST API directly if you want to. Hopefully this has been interesting. Hopefully it's kind of given you ideas of the kind of things you can build with very little coding actually involved. You can go and try out this stuff on developer.confluent.io. There's the demo scene repository that I showed you earlier on, but on developer.confluent.io, you'll find tons of tutorials, you'll find a bunch of podcasts and videos to get you started using Apache Kafka, using Confluent Platform. Thank you very much for your time.